Hey guys, today we have Dr. Gu Ronghui from Columbia University, who is a professor and he teaches formal software verification, being in this field for 10 years. And this is exactly the topic I wanted to talk to him about today, because formal software verification is a way to solve some of the smart programming or smart contract issues where, of course, if there's a bug in a smart contract, we have devastating effects. So Dr. Gu, can you tell me a little bit about what are the current problems facing smart contract development and why we need formal software verification?
Okay, sure. So first, smart contracts are quite different with traditional system software. Traditional system software, first is a black box. You can't see the source code in most cases. You don't know what is the source code for Windows, right? And when you try to attack it, so it's a black box, it's much harder. And second, traditional system software, they have, let's say for Facebook, for Google, first they have redundancy. Second, they do tons of tests. Third, once something, let's say, bad happens or some exception happens, they will, let's say, shut down the machine or stop the, let's say, some exchanges. They will stop you to cash out the tokens, right? So they have some mechanism, runtime monitor, some mechanism to protect the system. And also once the bug is found, they will do a patch to fix it and then let it resume, right, to run. But so you can see all these techniques are not, either can't be applied in the blockchain setting or not strong enough. Let's say blockchain, everything's open source. So the hackers now can read your source code to find bugs, right? And for a smart contract, once deployed, it's very hard to change, very hard to update. It's kind of like a real contract. Once you sign, right, even if there's bugs, well, you can't change it, right? So also you can't do this runtime monitor, right? And you can't easily add a patch for the DAO, right? You know that in order to prevent this loss, they use a hard fork and then generate Ethereum Classic, right? So you can see it's very hard to deal with. So and the testing, as I said, it gives you a percentage of guarantee. Let's see, I can make sure under 90% of the cases your code is correct, but it's not good enough. It manages that large amount of money, and everything is open source. The hackers will try to find bugs, even if it's just within that 10% or even 1%, right? So we need a way to improve the reliability and security of it, and can't rely on that. Well, later you can do a patch or you can do some runtime monitor. You can only do it as in a static way. I want to briefly explain what is formal verification. Many people are talking about formal verification, this concept, and especially in the blockchain world. So by formal verification, we usually mean to use mathematical ways to prove that the code, the implementation, satisfy your design, the developer's design. And we often call this design the specification. And kind of like you have some design in your mind that is one model, and you also have the code written in C, in solidity, in C++, and it also has an execution model. And formal verification is to prove that these two models are consistent. And as Vitalik said in one of his interviews, that all the bugs are caused by the difference between the implementation and the developer's intention. So you can see that the best way to solve the issue, to detect these bugs, is to prove that, well, your developer's intention and the implementation are consistent. And that is what formal verification can help.
Right. So it's the idea of combining and making sure that the intention and the implementation matches. But you know, I've always had a difficulty understanding this, because when you're talking about intention, that's always in terms of language. So I intend to, say, give you a token when you send me Ethereum. That would be a very simple smart contract. But how do you mathematically verify that? Because, I mean, to my knowledge, math doesn't understand language.
Yes, so the thing is, math can understand language, especially the rigorous language, like the code. Code is also, that's why we call it programming language. It's one kind of language, and we can even use the code to communicate, right? Some coders said, well, The best way to express my thought is to use programming language, to use code. So it's one kind of the code. It can be understood.
That's the most attractive type of guy, by the way. Someone who can only express themselves for code, definitely.
Yes, yeah, you can see that well code can be understood by human being, can be understood through math, can be understood by computers. But the thing is, computer or math can't understand people's mind, right? So we need a way to express our design, our the kind of what is the intention, right? So that's and it's really a tricky problem, and it's not that trivial. And there has been research along this line for many years, but we come up with a new language to write, to express your design. It's called a smart labeling, right? You can add labels, or you can view it as notations to your code to help us understand your intention, to help the computer, help the math understand your design. And we will extract a specification from that, a model or mathematical model from that labels, and then compare with that model, with the implementations model.
Right. So along the way, when you're writing your code, you're adding labels to the code. And then those labels help the mathematical build the specifications, in which case those labels are tested. So in essence, you're kind of writing the same code twice then, right? Because you're writing it once in Solidity and it's the second time in labels.
Yeah, it's a good question. So actually first is now we do it twice because we do it at different abstraction level. One is a code level. It's pretty small step. And you have to deal with many low-level details. And that is the code implementation. The reason is we want it to run fast, right? On the computer, you have to do lots of this optimization or whatever. And then the second time when you do it at a much higher level, right? You use our labels is pretty close to human natural language, and it's very expressive. You can use it to express your thought for the code. For developers, like let's say for engineers in Google or Facebook, they're required to put comments before the code, right? Because people think you need to, if there is a better way to help deliver the design of the code, help others understand your code, you put comments written in natural language. And in this case, in our case, let's say you also put labels, but you also put labels in the comments area, but that's labels now has the real meaning. We will extract the specification from that labels. Yeah.
Okay, so you talked about engineering in other fields as well. So not smart contract, but you're talking about Google, traditional software development. So with that, do they also have formal software verification as well? Is it also used in industry, or what sort of industries is formal verification used?
Yeah, it's a really good question. So formal verification, you can see the idea is really cool, right? We want to do the proof, this to match. Once they match, we are 100% sure that, well, it's correct, right? It's so cool. And we do the proof instead of testing. But you can imagine it will be very hard, especially for complex systems in the concurrent or distributed setting. It will always hate the so-called state explosion problem. Meaning that in order to do the proof, you want to cover all the cases, all the search space, but you will find, well, sometimes it's too large or even infinite, so you can't do the proof. That's why previously there's only limited application in the industry. So they use formal verification as some tools to help improve the reliability for some critical part, but not all. So it's already been used, but as I said, not that widely used. In Google and Facebook. Facebook has a team working on formal verification. They basically they only use it trying to detect the stack overflow in Facebook. So you can see there are some adoption. In 2015, Professor Zhong Shao, the other co-founder of our CertiK company, and we worked together. We figured out that the bottleneck of this formal verification techniques is not the way that how to do the proof. Actually, the bottleneck is how to write the specification such that we can decompose this proof obligation into many smaller ones and even utilize the layer structure of the system, the complex system software, and reflects this layer structure in the specification and verify each small components at the layer it belongs to, and then compose all the proofs together to deliver end-to-end guarantee of the entire system. That's our previous breakthrough technique. Breakthrough is called a deep spec. We introduced this deep spec concept when the deep learning is really popular at that moment. And now this concept has been widely accepted and studied by a broader community, including Yale University, Princeton, MIT, UPenn, and Columbia University. And we already held 2 summer schools and 3 workshops. And the last summer school was held in September. No, not in July, sorry, in July, and in Princeton. And we also invite Vitalik to give a talk, to talk about the potential collaboration, adaptation of the formal verification techniques to the Ethereum.
Oh, really? So, okay. So it was a paper that you guys published that brought this idea forward. Is there a reference to that paper?
Yeah, we have published a bunch of papers, including the multiple top-tier computer science conference like OICS 16. We present our results together with, let's say, some other great projects, including the TensorFlow from Google. We present our results there. And we also publish in PLDI. We have 3 PLDI publications, 1 POPO publications. Those are all top ones. And it's also been selected as the research highlight in the year of 2017. And yeah.
Nice. Okay, so, and the whole concept is to use a bunch of breaking down each individual system and using a proof there and then combining that to a bigger proof, right? So it sounds super logical. I just
it's very logical, actually. Yes.
Subsystem. Okay, sure. So one of the most infamous smart contract abuses was with the beauty chain contract, where an ERC20 token was exploited to create infinite tokens. So that was with beauty chain. Someone created almost a near infinite supply of beauty chain, sent that to exchange, and crashed the price to 0. So, what was the issue in that case, and could CertiK have solved it?
Sure, no problem. So basically, I can first explain what the bug of beauty chain. So kind of like it has a transfer function, and the first argument is that how many tokens you want to transfer to another address, and it will cast it to a 256 integer first to do the detection that whether your current balance, you have enough balance to do that transfer, to see that whether that's the value you want to transfer is less than your current balance, less than equal to your current balance. If it is the case, it will issue the transfer. So it's pretty natural, right? When developer write this kind of thing, well, it makes sense. Once you have enough balance, I can do the transfer and minus this amount from your balance, right? It's pretty natural.
Yeah,
but the
pretty natural.
Yeah, very natural. But the thing is, it first casts it into a 256 integer to do the comparison. And then when it's issue the transfer, it uses the original the value. It's kind of like, let's say, if this value is larger than 2 to the 256, 202 to the 255, and then it will cause an integer overflow and will be wrapped into, let's say, since it's unsigned, it will be wrapped into, let's say, 1 or very small number. And when you do the comparison, it's like, yes, it's less than your amount. So let's do the transfer. But when it really does the transfer, it uses the original one and issue this 2 to the 250, let's say 5 to 6 number of tokens, and then do this attack. So when we use
So essentially, let's just explain unit wrapping. It's just when there's a everything has to fit into memory, has to fit into a certain chunk of memory. And if that value is too big, if it's bigger than the chunk, it's like saying having a glass of water and filling it to the top and it flows over the top, there's a unit wraparound. So like if this is 0 and this is like a million, and if it's 1,000,001, a computer will assume that this is 1. It's so stupid. It's
very stupid. And once it got wrapped, it uses this wrap to do the comparison and find out, it's a very small number and you have enough balance. But when it issued the transfer, it used the
original value, not the wrapped value.
Not the wrapped one. So it caused the issue. And back to how we can how CertiK can prevent such kind of bugs. It's more like, well, before we need to write, before we execute it, we should add the labels to express our design, right? Basically, is you have the parameter says how much money you want to transfer, and the specification or the design should be like, if this number is less than equal to the balance, then we do the issue the transfer, and the balance left is the balance minus this value. And when we express this logic, let's say logic design, we don't need to care about this wrap thing, because that's the computer's implementation, because it has limited bits, right, to store the integer. When you write those, you don't need to worry about those. So you can see that when you compare these two models, you will find that, well, these two are different. Right. Because one is a computer execution model, which uses this integer, this limited bits of integer, and has this wrap and has this integer overflow. But your design says, I don't care how you implement this, but you have to guarantee the specification my design hold. So then it will detect the difference.
Okay. So one of the tags that you wrote, so just because I think you described this a little bit differently from the article that I read. So the article that I read, you explicitly said that this post, you specifically checked, you created a tag to check for an integer overflow. Is that necessary in what you described? Like, because when you described it, you said, okay, like this make sure that this matches. But is it necessary to put explicitly on a tag that there is integer overflow?
Yeah, it's a good question. So as I said, when you express your design, you have multiple ways. And what I just said is a very rigorous one. But for that, you need the expert, right, to write the specification, and which is not that easy for average developers. So we have some other tags that can help you send alerts or give you a warning. Like say, you can say that, well, I do not expect that my function will have an integer overflow. And this is also part of the design. So those tags actually now are built-in tags that will send you alert. Say that, well, here I'm not sure if you know that, but here we'll have an integer overflow. Please double check whether it's your intention or not. But for those, we can do so-called automatic verification to help you find many potential bugs. Yeah, but that's first, it's not strong enough, can't detect all the bugs. Second, it will also has false alarms. So, but that is just one technique that we use. But later, let's say if you want us to help you do the verification for your smart contract, we will do the one that I just said. It will give you a much higher guarantee. Yeah.
Okay. So there's two types of levels, right? So for a junior developer, you can build in a few functions. So for example, checking for buffer or integer overflows.
Yes.
And that can be enabled by default. So they can scan it and alert you if there is a problem. And if they're a more experienced developer in tagging, then they can build up the contract themselves. Or I think you said you can help them do that as well, right?
Yes, we can also help. We also provide services. So it's kind of like we want to educate people about this labeling language to encourage them to add those labels to their source code of smart contracts, or even let's say later the blockchain implementation itself. And once we have the labels, we can help you do the verification. If you don't have labels, we can use those default ones that, as I said, not strong enough, but still can help a little bit. And but we are also here to help. If you want to be listed on some big exchanges and you want to make sure that the trading, the transfer are secure, we can help you to write those labels, help you do the detection and find the bugs. And also we can provide a certificate showing that your smart contracts pass our verification, and we will send those certificates to the digital asset exchanges. So we have long-term collaborations with many of them. For example, we are incubated by Binance, and you may know that. And we have this long-term partnerships with Fobi Pro, OKEX, KuCoin, Gate, Fcoin, many of them. Yeah.
Okay. So what we said is just that, having this verification is damn important. So initially I thought that for something like this, it's computer or human, right? There's a competition. But what you're actually saying is that humans can use this as a tool. So it's not like competing with each other, but sometimes people can help each other use formal verification and use it correctly. And it's inputs from both sides, right?
Yes.
So is there any room for human error as well when we're doing formal verification?
Yes, it's a cool question. So indeed, it has a room for human errors. And we can prove that human being is always correct, always behaves correctly. So that's the thing. It's kind of like, let's say, if you express your intention in a wrong way, then we can't do much. Let's say we give you alert that here is an integer overflow. It said, yes, that's my intention. And you can't do much because that is how we define the correctness. That is how we define bugs. But as I said, we have a bunch of tools. We can see that here this is dangerous. It will give you the potential that all the tokens will be stolen or something like that. And that's why now we still need a human being involved to check the specification, whether it makes sense to you or not. And we can also give advices for the specification. Well, it might be a little bit dangerous. So that's why you can see that in our demo, we give you a score. We also explain why you got that score. We will present the certificates to the digital asset exchanges, let them decide, make the decision. We don't make the decision. We just provide enough materials. Yeah.
Okay. So we talked a little bit about how CertiK works. So in essence, it scans the code and it breaks down the code into little modules to kind of scan, yes. And then we get a score at the end. So yes. In terms of, okay, so now as a service, that sounds great. And one of the questions I've always asked is, why does CertiK need a currency? So yes. Can you tell me why there's a currency associated to such a service?
Yes. So one thing, as I just we just discussed, that here we still need some human efforts. There's still some human efforts involved, and that is just right specification and so on. But actually, for some proof obligation, it also can be done easily by human beings. We can also do proofs, right? We can, before computer is invited, we also do proofs by ourselves, right? And some proofs can be done easily by human beings, but it's pretty hard by computers, right? Computers has something is strong at, but something weak at. So that's why, like the loop environments, when you have a loop, sometimes it's very hard for the computer to detect whether this loop can terminate or not. And in this case, it might require us human beings to give some inputs. So that's why we still need human beings to involve. And that's one reason that we have this concurrency as a motivation to incentive people to participate into this business. That's one thing. Second thing is a bigger picture thing, like many people view blockchain as a world computer, right? As a world computer, and it's a hardware, right? Actually, it's a hardware. That's why EVM is called either a virtual machine, is a machine, is a hardware, and it plays a role in hardware. And the dApps, smart contracts, you can view them as applications, apps, right? We all know that nowadays, in early stage, the apps are directly running on top of the hardware. But now the apps are not directly running on top of the hardware, right? You have an iPhone, and it's also a hardware. The apps, there is a operating system called iOS running in the middle. What it does, so first, it will try to do some security protection, right? If you try to install a dApps from some untrusted party, it will prevent you to open the dApps, right? The apps. Except you break out the
jail.
Yeah. That's one thing. Second is trying to do some resource management, right? If some apps does not respond or consuming too much resource, it will kill that app. So something like that. So now you can see that the dApps directly running on top of the blockchain create lots of issues. First is the security, right? Security issues, safety issues. Second is also about the resources, right? One game like Formal 3D can block the entire network. There's no resource control of it. So we believe there is something missing. We need an operating system for blockchain world. And that operating system can't be a runtime operating system because it will burn gas. It's too expensive. It's a world computer. It's very expensive to do any execution. So if you have this runtime operating system running on top of it is too expensive. So we need some static operating system. It's kind of like there should be another thing running there that's before the launch of some dApps or smart contracts. That thing can statically provide, let's say, some security guarantee of the apps or some resources usage guarantee of that apps before the launch of it. It's kind of like before you launch, we will tell you whether it's safe or not. And once you have the certificate, then you can run. So that's what we aim for. We hope that CertiK can play this operating system role in the blockchain world, and such that for any public chains, whenever there's an apps want to be launched on it, it might try to, let's say, get a certificate from CertiK to see whether it's safe to execute it, whether it's, the resource is reasonable use. So that's the role we plan to. At least we can provide some hints that, well, if it's not secure, the users may not want to trust it. Let's say, almost ready, you may not want to put your money into that game, right? So,
well, to be fair, I think FOMO 3D is a bad example because people like pyramids and people are like, yeah, do you want to play a game that's a pyramid? Yes, boom. Yeah. You know, they still want to play. I mean, I think most people
they still want to play, but let's say later, if you have two games with the same mechanic, because it's code, it can copy and paste, whatever. It's easier to copy. There are some other versions of FOMO 3D, right? Even one on the US, and I believe it has some security issues. So at least you can choose which is the one you want to play. Right?
The one that's broken or the one that's a true pyramid? All right. Okay. Beyond,
people want to play with this in this game, but the people hope that it's a fair game, right?
That's true. That is true. When you're so in that respect, so what you want to do is provide this kind of third layer to check before any dApps is run. But right now, like, would you even go about executing that, right? Because Ethereum in its current roadmap doesn't have a plan to implement something like that. Can it be implemented, or do you have to choose another blockchain to implement it?
Yeah. So the thing is, so first, I try to use it to answer the question why we need a currency, because hopefully in the future, when there's a dApps trying to launch on any of the, let's say, reputable public chains, the chain may want to issue a request, definitely together with our token. Otherwise, we will not provide the service. And to get the certificate of that smart contract showing that it's safe to run and it will consume a reasonable resource, and then we'll execute it, or at least add a label to say whether you can trust that dApps or not. So that's our goal. And as you said, we need to collaborate with many public chains, and that is also part of our roadmap. We are pretty aggressive on the roadmap, and we have already established many partnerships with some reputable blockchains, like let's say NEO, Qtang, Ontology, let's say some new chains like QuarkChain, PayChain, Nebulous, and Waves. And also, I believe I already can reveal that we have some partnerships signed with Icon, the one in
South Korea.
In Korea. Yes, big one. So we have collaboration with them, and also there are many partnerships are under negotiation at this moment. So the goal is that we will help them add this one extra layer of protection. Yeah.
Okay. So it's just it's adding a layer of protection to make sure that when a dApp runs, that it's not messed up.
Yes.
The easiest way to say that.
It's kind of like later it's kind of like in iOS. Well, we provide certificates for those apps that whether it's safe to install and run on your iPhone. Yeah.
Okay, cool. So we talked about two use cases. One is to grow the community, and the other is as a currency to pay for services to get certificates from CertiK. Okay, cool. So lastly, about development as well. So how long has this been in development? What's the current development progress, and what do you kind of see in the future for CertiK?
Yeah, okay, sure. So first, for technology-wise or the theory development-wise, it has been many years, right? As I said, I've been in the field for more than 10 years. Professor Shah has been in the field for more than 30 years. And our two research labs, one in Columbia University, one in Yale University, are working on this target for many years. And in in 2016, we even built the CertiK OS, the world's first fully verified concurrent OS kernel. And it's being deployed on the so-called Landshark machine, a future wall machine. It's kind of like a future wall robotics. It's pretty cool. And yeah, it's already been deployed. So it's kind of like a useful technology. It has been demonstrated. So that's one thing. Second is that when we adapt our techniques to the blockchain world, the underlying engine, the theory part are almost the same. So, but we need to integrate our thing with some blockchain related front end, and that is what we are doing at this moment. We have pretty strong development team. Developers are former senior Google, Facebook engineers, and also our researchers in these two labs also play the research scientist role in the company, and we work together and try to integrate the different techniques. And you can see that we already launched our verification service. Although it's now being integrated into a ledger setting, but now it's still a centralized service, but we already launched the service and we already help many clients to do the verification, detect many bugs, help them fix them. And as I just mentioned, we also have this long-term partnership signed with many digital asset exchanges. So that's the current status. Yeah.
That's pretty good. So it's like, it's pretty amazing that, you know, all your research and all that you've been doing can suddenly fit into, you know, this is the perfect use case, right? In many ways, because, you know, I've been doing PhD research for science, and it's one of the things that I didn't finish because I realized that the application use cases were too small. But like, I think it's super lucky for you to have something that's like precisely what everything needed at that time. So yes. I'm really happy to hear this being applied. Now, one of the issues, of course, is with Solidity as well. It's a different language. So probably when you're developing the original systems for CertiK, you didn't know about Solidity. So how was the procedure of adding Solidity as part of the system, adding, like, you know, to be able to check Solidity?
Yeah, cool. So the thing is, so first we have a proof engine. That engine is language independent and also machine independent, hardware independent. So the engine is there for many years. We have built, and then for different languages, we need a different front end. Like this Solidity, we need a parser to kind of like transfer the Solidity code into the execution model. Right, and then compare and do the proof to show that this model and your design model are consistent. Right, we need that front end, and we are also working with many public chains to develop front end for them. Let's say Nebulous, they use JavaScript as a language to write a smart contract. Like Icon, right? They use Python to write smart contracts. Neo, they have the C# language to write. So all this, we are collaborate. We are working with them, build the front ends for them, and for, let's say, Nebulous, we already the front end engine is almost done, and we also help them do 2 smart contract verification already. Yeah.
Okay. So it's adding a front end and then parsing that into the engine. The biggest issue for me was that I heard for Solidity development, even the order at which you declare variables and functions is important. Just changing that order might even create a bug. So can that sort of information be safely parsed? You know, will the parsing process introduce bugs as well, or can we fully cover all the bugs potentially in Solidity that could be caused by language-specific issues?
Yeah, it's really a good question. So you identify the issues in this procedure, right? We do the parsing, and it might introduce bugs, and also the Solidity compiler may also introduce bugs, and also it changes, right? It also has different versions come out, new versions come out. It might introduce new bugs. So for this, currently, our solution is we just keep our parser engine consistent with the Solidity's latest compiler, because you want to transfer it to, you want to get an execution model from it, right? And that is also partially determined by the compiler. So these two have to be we have to make sure these two are consistent.
Right.
And that's what we are doing at this moment. But it's not, I would say, a good practice. So that's why we are coming. We are also doing research and development for two things. One thing is trying to develop a verified compiler for the smart contract language. It's very important because you do the verification, you do the code auditing for source code, right? But let's say the compiler has bugs, then it will break all the guarantees. So we want to build a verified compiler, but maybe not for Solidity, maybe for, let's say, a Vapor, some new language, and so on. Second, we are even trying to come up with a new language to write smart contract. It's called Deep Sea. Deep Sea, sea is the ocean, SEAC, Deep Sea.
Right.
And we will also provide a verified compiler for Deep Sea. And we hope that, well, this language will give you a higher level safety, security guarantee, and easier to write, have a better development environment. Yeah.
Right. So just having so the current step, you can match and make sure the versions of the compiler for Solidity and your parser match, and then in the future you want to implement something like Deep Sea where it's much more formally verifiable. Okay.
Yes,
perfect.
And also we will announce this Deep Sea in the coming summit, the Ethereum Summit in September 5th at Hong Kong. Right?
Oh, awesome.
Also be there. Mexico. There are many origin. I believe many projects will be there, and we will also present our Deep Sea language there. Yeah.
Awesome. Really excited to hear that. Dr. Gu, thank you so much for coming on and just telling us and informing us what are the current issues in smart contract development, and also what is formalification, of course, what is CertiK as well. So I'd like to thank you for your time, and hopefully in the future we can come back and visit a few events and hopefully not talk about disastrous bugs in Ethereum. So thank you so much for your time.